folks, so the first thing I'd like to say is, if you're just watching this without having had a go at the work, then you're not going to get the most out of this process. If you can print the sheets off and have a go at it, that would be great. Or if you just want to pause the video and have a go at each bit one by one and mark it as you go, then that's okay too. But do make sure you have a go before you watch me go through it, because you'll definitely get more out of it that way. So anyway, here's our first question. Peter's got £20,000 to invest. He's got two different accounts that he could choose from, and we've got to work out which one he should choose. So to do that, we need to work out how much he would get for each one. So the bonus saver is going to have 20,000 that you're going to multiply by 1.04, and then, and you can do it all in one go in the second year, 1.5% is 1.015. That's an increase of that. Put that all in the calculator and press equals will get you that one. The fixed rate, the same idea, 20,000. This time 2.5% is 1.025. You want to do that twice. You can press times 1.025 again, or just do 1.025 squared. Simple as this. 20. Oh, get your thing in the right place. 20,000 times 1.04 times 1.015. Press equals, gives you 21,112. Do the same thing for this one, and that should give you £21,012.50. So you are getting almost £100 more with the bonus saver. So at this point, to get full marks, you need to say choose bonus saver. Okay, here's question 2. So direct proportion, the sort of most solid technique to get through is to use the direct proportion sign, which looks like that, and then that means that there's going to be a number that you can multiply your L cubed by to get n. Oh, sorry, that should look like that, and then that goes to m equals k L cubed, and we need to find out what that number is. To do that, we put these values that we know in. So we know m is 160, we know L is 2, so it's going to be 2 cubed times k. So that means 160 is going to be 2 cubed is 8, so it's 8k. Find out what k is, we divide by 8. So we divide by 8 and we get k being 20. So that means I can say that my formula for m, knowing L, is going to be m is equal to, not 8, 20 L cubed. So if you're told that L is 3 and we want to know what m is, we just have to put 3 in to that formula. So it'll be 20 times 3 cubed. So you whack that into the calculator, 3 to the power 3, and that gives us 540. Okay, here's question 23, a density question. Now, density, you don't need to remember the formula for density because they tend to give it to you in the question. When you look at the units, grams are mass, centimetres cubed are volume, so you can say that that's telling us that density is mass divided by volume. And we need to find out what the density is of this wood. Now the radius of a sphere is 2 centimetres. The volume of a sphere is 4/3 pi r cubed. Now don't worry, the shape you're going to get in the test, you will be given the formula for the volume. So we need to whack 2 into there to give us the volume of the sphere. So it's going to be 4/3 times pi times 2 cubed. So pop that into the calculator. just use your fraction button, and then times, and pi is shift and the button down there at the bottom, times 2 to the power 3, press equals, and it gives you 32 over 3 pi. Now there's no point finding out what that number is as a normal number by pressing S to D yet. We're going to use that inside it. So the density is going to be the mass, which is 45 grams, over or divided by the 32 over 3 pi. Now when I do that in here, I'm just going to do it by doing 45 divided by, the calculator remembers the last answer that it gave you. So if I just press that answer thing, that will be dividing it by that. Press equals, and it gives me 1.34 grams per centimetre cubed. Will this wooden sphere float on the Dead Sea? Might be surprising because virtually everything floats on the Dead Sea because it's full of salt, but this is denser than that. So you're going to have to say, no, it won't float. Now if you guess that without doing any working, you get no marks. You have to do the working before to get that final mark. And there were 4 marks for that altogether. Moving on now to a similar shapes question, 3D shapes. But with 3D shapes, you've got 3 things going on. You've got the one-dimensional aspect of the pure dimensions, which is what's given here, the diameter of these cones. You've got the 2-dimensional, which is the area. So you've got the length, you've got the area or surface area, and then you've got the 3-dimensional, which is volume. Now the length is going to be the scale factor. Will tell us what is it. And now the scale factor is what you multiply the length by there to get the corresponding one there. 80 times 2 is 160. So that's going to be 2. For area, so if I knew the height of this, the height of this would be double it. But the area, whatever the area is of that, the area of this one will be 2 squared, which is 4 times the size. So the length will be 2 times, the areas will be 4 times, and the volume is going to be scale factor cubed, because it's 3D, is going to give you 2 to the 3, will be 8 times. So this first question here about how much paint we need, well, you're covering the surface area of the cube. So although paint comes in a volume sort of box, you're covering an area. So the amount of paint is going to be related to the area that you need. So if you need 80 millilitres for that one, you're going to need 4 times the amount for the second one, because that's got 4 times the area. So you're going to need 80 times 4, which is 320 millilitres. Okay. Now the next part is dealing with the same 2 cones, and it says the volume of cone A is 171,700. The volume of cone B is going to be 2 cubed, or 8 times the size of the volume of cone A. So all you've got to do is 171,700 times 8, which gives you 1,373,600 cubic centimetres. With volume, the numbers get bigger very quickly. Okay, we've got 3 trigonometry questions coming up. The first one's a basic SOHCAHTOA one, so have a go at that. Angle BAC is always the angle at the middle there, so I'm going to call that angle X. So looking at SOHCAHTOA, I can use that because it's a right angled triangle. I know 2 sides, so I can work out the other angle. And the first thing I need to do is label the sides. So this is the hypotenuse here, the longest side opposite the 90-degree angle. Opposite the named angle is the opposite, and next to the named angle is the adjacent, adjacent meaning next to. So what have I got? I've got the adjacent, I've got the opposite, nothing about the hypotenuse. So which one's got both of those? This has got not that. This has got adjacent but hypotenuse, so not that. So we want TOA. What does TOA mean? It means tan of the angle equals the opposite over the adjacent. So our angle we've called x, our opposite is 9, our area is 5. We're almost there. Then to find out what x is, we need to divide by tan. And if you've forgotten how to do that, have a look at your calculator, and just above the tan button it says tan to the -1, which is what we need, because negative powers are another way of dividing. So you go shift tan, it's already opened the bracket for us, pop the fraction in 9 over 5, make sure you close the bracket, press equals, and you get 60.94. Now it hasn't told us what to round it to, so you normally do it to 1 decimal place, so that would be 60.9 degrees. Moving on, here's an area of a triangle which has not got a right angle in. So normally you need a right angle. That kind of gets made with this special new formula that we've learnt recently, where the area of a triangle is equal to a half AB sin capital C. So capital C is the big angle. Now if you notice here, you've got A with little a there, B with little b there, C with little c there. We call the sides the small version of the letter that we've got on the corners. And what we need, what's significant here with the A, B and C is we need two sides either side of the angle that we're using. So we need this angle. So first thing to do is use angles in a triangle, add up to 180, add 54 and 39 together and you get 93 degrees. Take that away from 180 and you get 87. So that's an 87 degree angle. So now we're going to be using that as A, that as B, and putting it into there. So our area is going to be a half times 31 times 23 sin 87. So whack that into the calculator exactly like that. So 1 over 2 times 31 times 23 sin 87, make sure you close that bracket, equals 356.0. It wants three significant figures, so that's just going to be 356 centimetres squared. Right, now here's a feistier trigonometry question. No right angles here, so you're going to be either using sine rule or cosine rule to do things. We want the length DC, so that's that length there. So I'm going to call that x first of all because I need to get to that. But I can't do it with this triangle yet, because although I know the angles, and yeah, I know that's 80 and 40, that makes 120, so that has to be 60, doesn't it? Because they all add up to 180, but that's not helping me anyway. What I need to know is at least another length, so that I could use, if I know that angle there and that. Do you remember the sine rule is A over sine A equals B over sine B equals C over sine C. Basically what you need is if you want a length and you've got the angle opposite it, you need another length opposite another angle. So we need this length here, which we can work out using this triangle over here that's part of. Now, at the moment, that's opposite there. I could use the sine rule to find this angle or to find that angle. No, I couldn't, because I haven't got because I haven't got that length yet. So no, the sine rule's not helping me there. So the other rule I'm going to need to use is the cosine rule. And the cosine rule is that if you want to know angle C, C squared is going to be A squared plus B squared, which is a little bit like Pythagoras, isn't it? That's why it doesn't actually matter what order you put these letters in as such, but I like to go with it that way because A squared plus B squared equals C squared. I know that from Pythagoras. And then it's take 2AB, so you're timesing the two sides together that you know, that not the one that you want to know, and then it's cos, because it's the cosine rule, and the angle that's opposite that side, so cos big C. So looking at this here, that's what we've got going on. I want to know that, so I'm calling that y. So y squared is going to be that squared plus that squared, 8.2 squared plus 5.6 squared, take 2 times 8.2 times 5.6 cos 78. And it tends to put it in a bracket, so I'm just going to do that then anyway. Now, I don't like writing things out loads and loads of different times, so actually what I tend to do is think, when I've worked all that out, I know I'm going to need the square root of it, because I don't want y squared, I want y. So instead of writing y squared equals, I'm just going to cross that out and put a square root over the whole shebang, because you can put that into the calculator like that. You just hit the square root button at the beginning and then press 8.2 squared plus 5.6 squared, take 2 times 8.2 times 5.6 cos 78, close the bracket, press equals, and that's given me my answer straight away, 8.916. Now I'm writing more than 3 significant figures at this point because it's not the final length that I want, and if it wasn't for the answer button I would write all of those down. But as long as I use that answer button in a minute, I'm not going to need to. I'm going to put ... to signify that. So now we are going to use the sine rule to help us get that. I now know that that is 8.916 something. And I can say that my x that I want over sin 40, because that's opposite my length, is equal to y, which is 8.916 over sin 80. I don't want x divided by sin 40, so now a little bit of rearrangement. All I'm going to do is multiply both sides by sin 40, and that's going to give me x equals 8.916 sin 40 over sin 80. And when I pop that into the calculator, I'm going to do it like this. Press the fraction button, then press answer, and then sin 40, close brackets, over sin 80, close brackets, equals, and that's giving me 5.819. Now I've written 4 digits down, that would round up, but we don't need to worry about that because it wants it to 3 significant figures. So all that's important is what the 4th significant one does to the 3rd, which is rounded up. So our final answer is 5.82 centimetres. Okay, we're moving into statistics now, a little bit easier in a way. So, having a look at this, Harry's got 60 tomatoes. Now, what this question wants us to do is use the graph to estimate the median weight. So the median is going to be halfway if we line them all up. Now, as we don't know exactly what they are, we don't need to worry about going halfway between the 30th and the 31st. We just divide how many there are by 2 and say, right, the median's going to be halfway in there. Now, I should use a pencil for this really rather than a pen, and I'm going to draw a cross from where it says 30, right, median there, and then I'm going straight down. Only you can't really see where I've done that, just about, I suppose. And that's gone, so I've gone across from 30 using my ruler until I hit that line, and then I've gone straight down there to 170. So that's one mark there, 170 grams. Now, next up, it wants us to draw a box plot, sometimes called a box and whisker, for the 60 tomatoes in the group. The minimum weight is 153 grams. 151, 2, 3. So the minimum weight, you just put a little vertical line at one end. The maximum weight, 1, 2, 3, 4, 5, 6, put a little thing on there. The median weight goes in on a longer line here, because this is going to be in the middle of the box. Now, for the box, we need the lower quartile and the upper quartile. So that is quarter and 3/4 of the way through the data. So I need to find those out to go back up to here and draw that in. 60 divided by 4 is 15, so the lower quartile is going to come at 15, 10, 11, 12, 13, 14, 15. So the lower quartile, put LQ for that, and I'm going to use my pen just so that it shows up more. Normally I'd use a pencil. To there, and then straight down, and that looks like 160. 1, 2, 3, 4, 5. So that's 165, and then 3 upper quartile will be 3/4. So times the 1/4 by 3 equals 45. 1, 2, 3, 4, 5 is just there, and then again I'm drawing across carefully, and then I reckon that's hitting just there. So that's straight down there, and that's looking like 1, 2, 3, 4, that's looking like 175. So that's my upper quartile and lower quartile, which are going to be shown on here at 1, 2, 3, 4, 5 and 175, and then should really be using a ruler for this. My box goes off there, the whiskers are attached to either end of the box like that, and the significance of it is the most typical middle half of my data, my tomatoes, are all within there. My biggest quarter are spread in there, and my smallest quarter are spread in there. Now we're told that group B plants, the 60 tomatoes, the results for those are on there. Now, in order to compare them, I'm just going to try and bring the other results down here so we can see them all. What we need to compare is we need to compare the average, so that is the median that we've got here and here, and you also need to compare a range, either the range or the interquartile range. The interquartile one's the most relevant, so let's use that. So the interquartile range for group A is from 175 to 165, so that, but you can't write that, it's actually what you get when you take it away. So it's saying that the middle half vary by 10 grams. That's our interquartile range for group A, and the interquartile range for group B is 1, 6, 1, 2, 3, 4, 5, 6. Take 158 is 8 grams, so slightly smaller. And you can see that the average tomato for group A is much bigger. I mean, generally you can see that the group A tomatoes are bigger, and if you read it carefully, that's going to be because they used fertilizer. But when it asks you to compare the distribution, it doesn't want anything about your opinions of fertilizer. It just wants us to say about those differences that I mentioned. So first I'm going to say, on average, group A's tomatoes weigh how much more? 170. It was 170 as opposed to 162. 8 grams more than group B. Group B is a little more consistent, as, which just means that they're less spread out, doesn't it? As, oh, I haven't written B, group B, as their interquartile range, you're allowed to shorten that to IQR, is 8 grams to group B's 10 grams. So I've shown I know what the difference is in terms of both the interquartile range and the average and the median, which is what it's all about. Okay, question 9 is a histogram question. We've got to draw a histogram. Now that looks a bit like a bar chart, but it's not a bar chart in that you haven't got frequency going up the side, and it's not about discrete data, it's about continuous data, so there's no gap between the bars. And the first thing to do is to set yourself up 2 extra columns, because we are not going to plot against frequency, we're going to plot against something called frequency density, and the frequency will be represented in the area of the bar. So what I need to know is how wide the bars are, because the bars are different widths. From 0 to 20 is a width of 20. From 20 to 30 is a difference of 10, so that's only going to be 10 wide. From 30 to 45 is 15, and 45 to 50 is just 5. Now to get the frequency density, what you need to do is divide the frequency by the class width. So 16 divided by 20 is 0.8. Remember to use your calculator if you need to. 27 divided by 10 is 2.7. 36 divided by 15 is 2.4. And 6 divided by 5 is 1.2. Now this is going to be the height of our bars, and then notice down the side here there's nothing on here, so my biggest frequency density is going to be 2.7. Now keep it simple when you're doing this. Have a little look at how many squares you've got and try to split it up. Now I think 1, 2, 3, 4. Every 5 I'm just going to put in a little 1, 2, 3, 4. 1, 2, 3, 4, 5. A little mark so I know how far up it is. There's another 5, there's another 5, there's another 5. Right, and I've got to go up to nearly 3, so that could be 1, that could be 2, that could be 3. That's going to be easy. I don't have to use all of the y-axis if I don't want to. What is important though, you lose a mark if you don't do it, is that you write frequency density up the side, and then what's on the bottom. It was about rainfall, and you need the units in there, so that was rainfall in millimeters. And then we need to have zeros marked on our axes. They do not like it if you don't put those in, you lose marks. Now again, right, there's 10, 20, 30, 40, 50, oh, and it's going up to 50, so that's perfect. 30, 40, 50. And then you just draw in your bars according to how high the frequency density is and how wide it should be, which should give you something like this. And then we've got one little question on the bottom. One of the weather stations is selected at random. Work out the probability that the rainfall recorded was over 40 millimeters. Now 40 millimeters means all we're interested in, everything from there and that bar. Now I know how many's in that bar because it says it in the table. There's a frequency of 6. So that's 6, but how many there? Now you might spot it's a third of everything that you've got going on there, or you could say the frequency density is 2.4, and the width of that bar there, is 5. So 2.4 times 5, what's that? That is 12. So it'll be 12 plus 6, or a third of 36 is 12, so that works. So you've got 12 plus 6 makes 18 weather stations where the rainfall recorded was over 40 millimetres, sorry, 40 metres would be a crazy amount of rain. And how many weather stations are there? Well, it says right at the top, 85 weather stations if you add all the frequencies up. So 18 out of 85 is 3 marks. You're going to get 1 mark for having the 85 on the bottom, and the other 2 marks come for getting those 6 and that 12 there. Right, inequalities on a graph now. So in order to do this, we need to plot the lines of x plus y equals 4, y equals 2x plus 1, and y equals minus 1. But we've got to be careful when we do it, not to do them as solid lines, but dotted, because there's no or equals here. It's got to be one, it's all going to be on either one side or another, depending on which is the right side to do. So let's go one at a time. Y equals minus 1 is, I think, the easiest. Now again, you should be doing this with a pencil, but just so you can see it clearly, I'm going to do it with a pen. Anywhere on this line, your value for y is negative 1. So I'm putting a dotted line going all the way across there. We're going to want y is bigger than negative 1. So bigger than negative 1 is going to be above there, isn't it? So I'm going to put a little arrow there and there to remind myself that's where my region is going to be shaded above the line. Then let's look at this one. This, if you use y equals mx plus c, remembering m is the gradient and c is the y-intercept, well, our c is plus 1, so I'm going to put a point there. And then the gradient is 2, so that means in the time I go along 1, I go up 2. Put another cross there. Then in the time I go along 1, I go up 2. Running out of room there, so let's work backwards. Back 1, down 2. Back 1, down 2. So my straight line is going through those. And again, it's going to have to be a dotted one. Like that. And finally, x plus y equals 4. This can confuse people, but actually I think it's the easiest one, because you just need to plot 2 points. The point where x equals 0, if x is 0, y will be 4, because 0 plus y is 4, so y must be 4. So if x is 0, y is 4. And likewise, you could say, well, if y is 0, cover up y, x will be 4. So 4, 0 would be there. And then I need to put in my dotted line going across here. Oh, now what side are we shading for both the last 2 ones that I've done? Well, first of all, if we look at this one, x plus y is smaller than 4. Well, I think this looks above and this one looks below, and we want it below. But if you're not sure, double check by picking any point on the side that you think it might be. I think it's going to be this one. My x value is 1, my y value is 2. 1 plus 2 is 3. That's less than 4. That's true of any of the points under there. So we're going to be shading to this side of that line. And again here, we want y is bigger than 2x plus 1. So that's above the line. That's on this side. If you were to drop a ball, it would roll down there. Or, if you were to pick a point, like that point there, my x value is 1. Well, this formula would say y is going to be 2 times 1, because 2 times x plus 1 is 3. Well, 5 is more than that. So this is giving us y being more than 2x plus 1. So it's the right place to go, above that line. So we've got to shade the region which is all of those things, or label it R. So just shading that in quickly, that would be all of this stuff here, but it did say label it R, so let's put an R on it. Okay, final question. So we're going to complete this table of values, and then we're going to plot the graph from those values there. You've got a calculator. The easiest thing to do is to use the calculator. Turn it on, and you want the table function. Now, for most of the calculators that we use in school, it's number 3, but on this calculator it happens to be 9 table. But once you've got your table function, so it's probably going to be 3, press equals, you should have function x equals, and that function x, just pretend that says y. And we've got to put x cubed plus 2x minus 1 in there. To get x in there, you do not press that, you want that x there, so that's a pinkish red colour. So we get that with the pinkish red alpha. Press alpha x. Then we want it cubed, so now I press that one there and put a 3 in that box. Use the cursor keys to come out of there, plus 2 alpha x, take 1. Now I've got, just double check that's exactly the same, press equals. That's for if you're going to plot another graph at the same time. We don't want that, so I'm just going to press equals again. Start. I want it to start at -2 when x is -2, so I'm going to put in -2, press equals. I want it to end not at 5 but at 2. Press equals. Step 1, that means I want it to go up in ones. Yes, I do. Press equals, and here's my table of values. When x is -2, f is -13. I can even check that I'm right, because look, when x is -1, that should say -1 there by the way, and that should say -2, then you're getting -4, which is what we've got there. -13, -1, when it's 1 it's 2, and you might think, oh, where's the other value? Just press the cursor keys down to go down below and you get 2, and that's 11, so that's more reassurance that I've definitely done this right. Now I need to plot those 5 points on here. So -2 and -13 is all the way down there. Then -1, -4, just there. Next up is 0, -1, followed by 1, 2, and finally 2, 11. And then you do not join these up with straight lines. You now need to sketch, and this is worth using a pencil for, and I like to use little lines just to gradually put the curve together. Do not worry if you're not a brilliant artist and you don't find this easy. As long as it looks something like it and it's basically a curve, you'll be okay. Now that's going to keep on getting steeper and steeper as it goes off the graph. Right, so that's my curve, and there's one final little question, folks. Use your graph to estimate the solutions of x cubed plus 2x minus 1 equals 3. You might be thinking, what the flip's going on there? Well, the only difference there is that it says equals 3 instead of equals y. So we want to know what values of x are going to make y equal 3. And all you do is you go to 3 on there and draw across. I'll just dot a little line across horizontally until I hit my curve. Now everyone's curve is going to be slightly different, so there's a degree of tolerance allowed, so we don't expect everyone to get exactly the same answer on here, but what we do need to see is you reading it accurately off wherever your curve has ended up being. So I am just, there's 1, there's 1.1, 1.2, oh, I think that looks like it might be x equals 1.15, and that is actually the only solution. It said estimate the solutions, but there's only one there. If this curve had been going up there somewhere and that had hit there, then I would have had another place to read a solution off. Right, now I know I've been going through pretty quickly on that, so If you did find anything confusing, pause the video, go back, watch it more than once. But if you're still confused, come and see me and I will run through and try to make things a bit easier for you. Okay, thank you very much and good luck next week. Cheerio.